Hey guys, this is a video that's going to cover how to factor when you have a trinomial in standard form, but the a, the number in front of the x squared, or in this case p squared, is not 1. So just remember, if this was a 1, you'd factor this way differently than what I'm about to show you. This is more of a longer way when you have a variable squared, another variable, and a number. So this is written in standard form. It's a trinomial, and the number in front is not 1. So you have to follow these steps every time in order to factor it, which means in the end, we're going to write it as a multiplication problem. These always will factor into a binomial times a binomial, that if you did multiply it, you'd end back up at the beginning. So remember, we're factoring it. First step is to always take the first number, the a, and multiply it by this c, which is the last number. Remember to keep in mind if it's the last number and the first number, whether they're negative or positive. In this case, you have a 3 and a negative 5. And when you multiply a times c, you get negative 15. And now you're looking for the two things that multiply to negative 15, but they also have to add to that middle term, which is negative 2. So there's a lot of things that multiply negative 15, like negative 15 and 1, but those do not add to negative 2. So if you keep going, you'll eventually come to negative 5 and positive 3. And remember, it has to be a negative 5 and not a positive 3. I'm sorry, and a positive 3, but not this way around, because this would not equal negative 2, it would equal positive 2. Once you find the two numbers that do those things, you are going to write a 4-term polynomial, which means you're going to take this expression and you're going to write it exactly the same way, except you're going to split up the negative 2p. So I have 3p squared, and also in the end I have negative 5. But then we're going to take the negative 2p and we're going to write it as the two numbers we found out that met the original criteria, which was multiplying to negative 15 but add to negative 2. So we knew that they were negative 5 and 3. So negative 2p is going to split up into negative 5p and positive, so plus 3p. So everything else is the same, but I wrote it as a 4-term polynomial. You're also going to notice that it doesn't really matter the order that you put these in, as long as the 5 was negative and the 3 was positive. So the next step, that once you write it as a 4-term polynomial, you're going to do what we call as grouping, which means you're going to group the first two, and you're going to group the second two together. And then, just like you learned in the class before this, you have to find the GCF of the first grouping, and then you're going to do the same thing for the second grouping. So in the first grouping, the greatest common factor is the numbers are different, but they have a p in common. So you can factor out a p, and inside you have, when you divide each of these by p, you have 3p minus 5. Now over here, there's nothing to factor out because there is no greatest common factor. But when that happens, you still have to consider there to be a 1 in front. So it's like there's a positive 1 in front. If there was something to factor, you'd factor it out. What you're going to notice is that you have the same thing written inside the parentheses. And because of that, you really, when you're multiplying the same thing to two separate terms, you could actually put the p and the 1 in parentheses as p plus 1. And put the 3p minus 5 written once outside the parentheses. Because these two terms, I'm going to say that's 1 and this is number 2. Number 1 and number 2 are essentially saying the same things, but here we were able to write this as the multiplication of two terms. And this is what we were talking about in the very beginning. We have broken this problem down into a multiplication problem. This times this. This is the factored form. And if you want to double check, if you do 3p minus 5, times p plus 1, and you distribute the 3 and you distribute the negative 5, or a lot of times it's referred to as FOIL, you will eventually get back to the original expression. Right? So let me show you another one so you understand this a little bit better, because I know there's a lot of steps involved. Okay. Here is a trinomial. It's written in standard form, and I noticed that the number in front of the n squared is not a number 1, so we have to go through these steps again. So first we're going to multiply a times c, and you get negative 18. So we're looking for the things that multiply to negative 18, but that add to a positive 3. And that would be positive 6 and negative 3. So now that we know what those two things are, we're going to write it as a 4-term polynomial. But instead of positive 3n, we're going to break that up into plus 6n and minus 3n. The two things that we found in the very beginning. Now remember, we're going to go ahead and we're going to group these two and these two together. The greatest common factor here is a 2n. So when you factor that out, you end up with n plus 3. Here, this is negative 3n, negative 9. So the greatest common factor is actually a negative 3. And when you take out a negative 3, you're left with n plus 3. And you're going to notice you have the exact same thing written inside the parentheses. So we can write it once and take the two things, the other things that we're multiplying the n plus 3 by, and put them in their own parentheses. In this case, it's a negative 3, so 2n minus 3. And this is now the factored form of the original problem, which if you did multiply it, you would end back up at the original. This and this, oops, sorry, are essentially equivalent expressions, but this is in factored form. Now, if you're having trouble with this part right here, there's a video on Westland Math that says factoring using the GCF. That's what we've done before. You can watch that video as well. So now, I just want to talk about two different cases before we go on and before I give you a chance to practice. First of all, there are going to be times, and we actually already did a problem like this, so I think you already know this, but there are going to be times that when you're factoring out, if this was the 4-term polynomial, and you were taking the greatest common factor of each, in this case it is 10, you're left with x plus 5. Just remember that if there is nothing to factor out, you still have to consider there to be a 1 in front. So this would factor into 10, and then there'd be plus 1, which that actually you would be able to simplify that. But I just wanted to remind you that if you were factoring it out, you really have to take out the 1. So here, I'm going to add a x there. So in this case, let's say this was your 4-term polynomial, and this actually happens quite a bit. This is a little bit of a confusing thing. When you take out the greatest common factor here, it's 2x. And you're left inside with x plus 5. I'm sorry, negative x plus 5, because this was a negative 2. So when you factor out a 2, you're dividing by 2. Negative 2 divided by 2 is negative 1x. Here, you factor out a 3, and you're left with x minus 5. So if you look closely, they're almost the same inside the parentheses, but they're not exactly the same. So when that happens, really you should notice that all you have to do is change the inside of the parentheses to the opposite. And you can do that without changing the problem as long as you also bring out a negative in front. So 3 times x minus 5 is really the same thing as negative 3 times negative x plus 5. If you multiply this in, you get the same exact thing. So I'm able to do that because now you have the same thing written inside the parentheses. So if that ever happens, just factor out a negative 1, and now you're left with 2x minus 3 on the outside, so that's in one parentheses, and then the negative x plus 5 in the other. And that's a way that you can take care of it if for some reason it's not exactly the same inside the parentheses, but you have the opposites. So now what I want you to do is I want you to pause the video, and I want you to I want you to try each of these on your own. And then as soon as you're done, we'll go ahead and, if you play the video, I'll show you the answers all done out already for you. And then you could check. So go ahead and pause the video and replay as soon as you're done. Okay, so hopefully you got a chance to do these problems. A couple things I want to point out. First of all, you can, after I'm done talking, you could pause the video so you can look at all the answers and hopefully get someone to kind of explain if someone doesn't understand how you got the final answers. The final answers, remember, are on the bottom. Oops, sorry about that. I want to highlight a couple things for you. First of all, let me highlight the answers. Remember, the answers are the factored form at the bottom. Now, all my steps are shown. At the very top, I multiplied a times c. So this is how I figured out what these little inside terms were, because I knew that in this one, what are the things that multiply to 10 that add to 11, 10 and 1. Here, what multiplies to 60 and adds to 19, 15 and 4. And here, what adds to a positive 12, but multiplies to positive 12, adds to a negative 8, that's negative 6n and negative 2. Or negative 6 and negative 2. And then remember, you put the variables. Here, you actually got the problem where you had n minus 2 and negative n plus 2. So originally I had factored out a 2, but then I just put a negative sign on the outside and changed everything inside to the opposite. And that way I was able to get the same thing inside the parentheses. So your final answer was 3n minus 2 times n minus 2. So one more step I want you guys to do. Here are 4 problems that cover not just the factoring you learned today, but all of the factoring that you've learned so far. It's not all the factoring that you're going to learn, but they're all the factors. Here's a binomial. Here's a trinomial, but a happens to be 1. Here's one where it's going to be a little bit tricky, and here's one of the ones you learned today. So try these 3, and then when you're done with those, try this last one. Give you a little hint. This last one actually covers all the different types of factoring that we've done. There's more than one way you're going to factor this by the time you're done. And then I'm going to go over these step by step as soon as you're done. But go ahead and you could pause the video, and as soon as everyone's done, I will go over the answers with you. So hopefully now you got a chance to do these problems. The first one is just a binomial, so all I do is factor out. I can factor, but by using the greatest common factor. And when I factor out a 5x, I'm left with 1 minus, and then 45x would be 9x. And that's the factored form of this. Here's one that we did, one of the ones we did today. So I multiply a times c, and I get a 4. And first of all, you always want to check if there's a greatest common factor, and here there's not to take out. So things that multiply to 4 that add to 5, so that's 4 and 1. So here's my 4-term polynomial. I'm going to group these and group these. Greatest common factor here, that's, sorry, these are all n's. Greatest common factor here is a 2n. I'm left with n plus 2 inside here. It already says n plus 2, so you just consider there to be a 1 out in front. So the factored form is 2n plus 1, and then the other thing inside the parentheses is n plus 2. Here, it has a 1 in front, so you didn't have to do any of these steps. When it has a 1x squared, you could just factor it into the 2 binomials automatically, and the 2 things that you factor them into are the things that multiply to 63 that add to negative 16, and that's negative 7 times negative 9. So your factored form is automatically x minus 7 and x minus 9. Here, you take out a greatest common factor first. So when you take out a 2, you're left with x squared plus 9x plus 8. And then if you look inside, this is one of those ones like this one. So you can notice that it's a 1x squared. So these are really easy to factor. You just look for x squared gets broken into x and x, and looking for the 2 things that multiply to 8 that add to 9, and that's 1 and 8. And I have the 2 on the outside, and this whole thing is the factored form. You're actually multiplying 3 things. This times this times this. And that is the how to factor.